Hello everyone, welcome to this video where we will discuss about video optimization for websites and apps. I have a sample application ready. It's going to be a long video, but at the end of it, you will have a list of things that you can try out depending on your business use case to ensure that your videos stream perfectly, you're delivering the right user experience, and as a business, you're saving on data streaming costs as well. So let's get started. Now, video optimization is a bit complex, right? If you have done image optimization for your websites and apps, it's fairly straightforward. There are a bunch of audits that tools such as Lighthouse or Web Page Test give. For example, compressing your images using the right format, such as WebP or AVIF, or resizing your images, lazy loading them. You can just follow the best practices and you would be able to optimize images for your websites and apps. But when it comes to videos, there is no such standard tool that gives you a list of video optimizations that you want to do. It really depends on what's your business use case. Where are you loading your videos? How do you want your users to interact with videos? That will help us decide on what kind of video optimizations that we go for on our website and app. But there are four basic principles that we'll follow throughout this video, right? So we want to load our videos faster. We want to load lighter videos or lesser amount of data on the user's device. Because videos stream over time, we also need to ensure that whatever videos we are streaming on the user's device, they adapt over time as well, because the way that the user interacts with that video over a period of time, that will change, right? So we need to ensure that our videos adapt over time. And we also need to ensure that we are loading these videos as late as possible and we are actually waiting for the user to actually be looking at the video, and that is when we start loading the videos, right? So this is true for any kind of optimization, not just videos, but these four principles is what we are going to stick to throughout this video. So first, let's take a look at the sample application that we have and the setup that we are going to start with. I have this page, which is like an article page that you would typically see on websites on the internet. There is a video that plays in the first element. Let me just refresh this. So yeah, this is the video that will autoplay. This video currently is being delivered via CloudFront CDN, and the original video is stored in an S3 bucket. It's a MP4 video, 44.4 MBs in size. And we're going to be starting from here. This is a simple video tag that's being used to play the video. We'll start from here and we look at different ways in which we can optimize our video assets. Now, all the code for our application is available in this GitHub repository. You can head to github.com/ImageKit samples, video optimization. We'll put a link in the description as well. But you can copy the entire code from this repository of whatever we discuss in this video, right? So I'll just walk you through some of the sample code. In our application, we have a JSON file which sort of mimics the response that you would get from a backend API. You can see that the first element here, it has a media type set to video, and the media URL is just driving trip.mp4, which is the path of the file that we have in our S3 bucket. And then we have a React component which has a road trip card, which is the card that renders the actual output that you see on the website. And if the media type is video, then as of now, I'm using a React component which uses nothing but a simple video tag, right? So this HTML5 video component, it uses a video tag. It accepts a bunch of parameters as well, but essentially it loads the video via the CloudFront CDN that we just saw. So at this stage, there are no optimizations that are happening in the video. We are just delivering the video as it is, but we are using a CDN. Which brings me to the first optimization that I wanted to discuss, which is that you should always use a CDN for your video files, right? So let's assume that your video files are stored in, let's say, a cloud storage like S3, and you're based out of the US, and your users could be spread across different countries, or maybe, let's say, even different regions within the same country as well. One way is that you could deliver these files directly from the S3 bucket to the user, which is basically everyone accessing the files from the same storage location. The other way is to use a CDN in front of your storage, right? Which is the most common setup that almost everyone uses, that you connect your CDN edge. Now, let's say this CDN edge could be on the West Coast, let's say in California, and this CDN edge could be on the East Coast. Let's say this could be in New York, right? Now, if there are users who are on different sides of the US, right, and they're accessing it from different locations, instead of both of them accessing it from the same location, they would access it via the CDN. The CDN typically for a high traffic website would keep a copy of your video cached over here. which means that for subsequent access, the access would be really fast, right? Because this user who is sitting on the West Coast is now downloading the assets from a CDN edge, which is closer to them, instead of traveling all the way to, let's say, a bucket that was located on the East Coast, right? So if you were to load directly from this S3 bucket, the user on the East Coast would have gotten it faster, but the West Coast would have been slow. But if you use a CDN in front of your storage, then both the users would get content via the CDN edge, and the CDN edge would be serving the video from its own copy, right? Which is what would make the access faster, right? So always use a CDN in front of your S3 storage or any cloud storage that you're using. That's the basic of making your videos load faster. While the CDN helps us to load the videos faster, we actually need to reduce the size of the video that's loading as well, right? Currently, we are loading a 44.4 MB of MP4 file, which is not ideal at all. So we need to think about how do we reduce the size of the video file as well, which brings me to the next optimization, that how do we compress a video and choose the right format or codec for the video, right? Very similar to what we do for images, where we need to compress them or we need to convert them to formats such as WebP or AVIF. We look at what is it that we can do for videos as well. Now, in this case, I'm going to be using ImageKit to do all kinds of video optimizations that we see in this video. But you're free to use any tool of your choice. The basic fundamentals are the same, right? Whatever we discuss in the video can be achieved using other tools as well. But I'm going to be using ImageKit for this demonstration. I already have in the sample application a component called ImageKit Video, which basically uses the video component of the ImageKit React SDK, right? So if you head to our documentation under Quick Start Guides, you will find an entire documentation of integrating ImageKit on your React application. I'm using this video component that, amongst other things, it accepts the source of the file. We are going to be using the same S3 file that we started off with in the beginning of the video. But instead of loading it via CloudFront, I need to load it via ImageKit. And the way to do that is that in your ImageKit account, you can connect any external storage. I have connected the same S3 bucket with my ImageKit account. Again, this is documented in our documentation at how do you connect an external storage like S3 or GCP, etc. And then you need to connect it to a URL endpoint. So you can see that the bucket that we're using, demo integration 1, that's connected to a URL endpoint in ImageKit. And we now need to load the video using ImageKit, which is what you see over here. The URL endpoint is set to my ImageKit URL endpoint, which is over here, and the source remains the same, right? So what I'll do is that in my road trip card, instead of using the HTML5 video component, we now switch to the ImageKit video component, right? And just by doing that, if I come back to my application and I reload the page, you can see that the file now loads from ImageKit, and the content length, which is where you actually see the complete size of the video. The video will load in chunks, but if you want to see the total length of the video content, that will get loaded. So you can see the content length over here. This is approximately 8 MBs. So you need to divide it by 1024. So this would be approximately 7.8 MBs, right? So we started off from 44.4 MBs of MP4. This is down to 7.8 MB of WebM file, right? Because I am using Chrome. So ImageKit has this functionality where it automatically optimizes your video format and it automatically compresses your video as well, uh, whenever you deliver it based on the end user's device. So in this case, I am accessing it from Chrome, and you can see my file is now compressed and it is also converted to the WebM format, right? So when it comes to video optimization, there are two things that we need to be able to reduce the size, right? So very similar to what we did for, or let's say what we do for images, that we need to convert it to the right format. So for videos, the right format would be WebM, or it could be MP4, right? And for videos, these are just container formats. So what a container format is, that it consists of your video stream, your audio, your subtitles. It just packs everything together. The main compression happens using the codec, which is the short form for encoder decoder. So in WebM, we use a VP8 or a VP9 codec. ImageKit uses VP9, and similarly for MP4, we have the H264 or 265 codecs. These are basically the algorithms which decide how does a frame in a video get compressed, or how does, let's say, data between two frames get compressed. So it's actually the codec that determines how much compression would come for a video, right? And then we need to adjust the bitrate as well in a video. So bitrate can be bitrate is basically the amount of data that you stream per second. It would be usually measured in kbps or mbps. So for a particular codec, we also adjust the bitrate that needs to be used for a particular resolution for delivering the video. So by doing these two things, or by optimizing the right container format and the right codec, and by changing the bitrate of the file, we are able to bring down the size of the file that loads on a user's device, right? So these two things get taken care of automatically when you use ImageKit. Now, moving on, just like for images, we need to resize images for every placeholder that you have on your website. We need to be able to resize the video as well, right? Which brings us to our next video optimization, which is you need to reduce the video resolution as well. Now, imagine a mobile device very similar to the simulation that we have over here, where it's a vertical viewport. And let's say the device width in this case, let's say this is 450 pixels. And the video that I actually have right now is a 1080p video. I'll just open it in a new tab. This is a high resolution 1080p video. Now imagine that for a 450 pixel wide device where the video container is actually even smaller, with if you leave out the margins of the side, and then the height of the player is, let's say, 400 pixels as well. So we need to resize our video to something that's more reasonable for this particular placeholder. Instead of loading the 1080p video that we have, we will bring this down in size and reduce the resolution, which will help us reduce the size. So in ImageKit, we do have this feature where I can add the width transformation, or let's say I can resize a video in real time, right? And I can pass this as a parameter to my video component itself. It's an array of transformations that I can pass, but in this case, the only transformation that I want to pass is the width, right? So if I set the width to 900, you can see that if I now reload my application, the video now has a parameter W900 added to it as a query parameter. And if I open this video in a new tab, you can see that the video height is much smaller, right? So we have reduced the resolution of the video, which in turn helps us reduce the size of the video that gets loaded, right? So we are now down to approximately 2.9 MBs of video. We started with 44.4. By compression and using the right codec, we were able to get it to 7.8. And now we are at 2.9 MBs of video for the WebM file, right? So by just doing these two steps, we have been able to reduce the video size by almost 90%. Now, in this case, again, I've used ImageKit to resize the video. You can possibly use any other tool as well of your choice to reduce the resolution, but it's just fairly convenient. By adding a parameter to my video URL, I'm able to bring down the resolution and I'm able to reduce the size of the video that loads on this device. Now, these two optimizations can be applied to almost any use case that we have for videos, right? And if you're using a simple HTML5 video tag to play your video, you should always compress your video, convert it to the right format to use the right codec, and you should resize your video for that device. A more aggressive optimization strategy, it depends on where you're loading your videos, would be to remove the audio completely, right? So you saw when I played the video that the video in this case actually has a soundtrack as well. I'll just play the video in a new tab. You can see that the video has a soundtrack, but imagine if you were playing this video as a background video, let's say in the banner over here, right? Where you do not need any sound at all. Now you might think that that's not a big difference, but let's just give it a try. If again in ImageKit, I have this as a parameter, I can pass audio codec as none. And I'm not getting an autocomplete over here because I'm using a component on top of the video component. But if you were to use the ImageKit video component directly and pass the transformations directly to the React video component, you would get a pretty nice autocomplete as well. But let's say if I pass this audio codec none, you can see that there is an additional parameter that gets added to my video. And now the size has come down to 2.6 MBs, right? So we were earlier at 2.9 MBs. Now we are down to 2.6 MBs. That's, you can see that my volume control is now disabled because there is no audio track at all that has been loaded with this video. Now this might seem small, but this is approximately a 10% of reduction for your video size, which at scale, let's say you're delivering terabytes of data, 10% of reduction in your total data transfer cost would be very significant. And this is only applicable if you're using videos, let's say for a background video where you actually do not need to load an audio file at all. So this is a very aggressive optimization, but if it is something that your business use case allows, then you should try to remove the audio completely, which would help you lower the size. Now, up until now, we have used a very simple video player setup, right? We're just using the standard HTML5 video tag. We are using a single video file and we are loading it for all devices, right? So even if I change my device width or if my network condition changes, the video that I'm loading actually still remains the same, right? So those of you who have used YouTube, and I'm assuming everyone has used YouTube, you would have seen that YouTube is able to adjust the quality of your video and it is able to switch between different resolutions of your video as your video plays over time and as your network quality changes or as your device orientation changes. So we'll now look to implement that, right? That how do we adapt our video over time? Because unlike images which get downloaded once and then they just stay on the screen, a video plays over time, and it is fairly possible that for your videos, while the user is still playing the video, the way that they interact with the video, it changes, right? So before we get to discussing that, let's just first understand the difference between the streaming that we are doing right now, the video streaming, which is the progressive streaming that we are doing right now, and the adaptive streaming, which is what we are getting into, or which is what YouTube does. Like, what's the basic difference between the two before we discuss about optimizing your videos with adaptive bitrate streaming, right? So in the video that we have right now, we have a single MP4 file, right? So this is an MP4 file. Forget about the output format, but this is, let's say, a 30-second MP4 file. When we load this in a video tag, the player or the browser actually makes what we call a range request. So it tells the server that, okay, give me bytes from, let's say, 0 to 10,000. I'm just putting a number here. The server actually sends it back this amount of data, and as your video starts playing, let's say your seek bar reaches somewhere over here, then it says that, okay, give me from 10,001 to up to, let's say, 20,000, which is, let's say, the complete length of the video, right? And then your server responds with the rest of it. So the browser and the video tag, they actually handle this streaming for you, and you would see this in the response status code, which is the 206 partial content. You would see that your server responding with a range instead of the entire content length, though in this case the request was actually for the entire content length itself. But you would see a range request header and a content range response header in this case. But it is still a single video file that is being played, and it is the browser that is actually making requests for different parts of that video. When it comes to adaptive streaming, when we need to adapt that video to different network conditions or to different device conditions, we're starting off with one original file. Let's say we call this as original. And then we encode this into different resolutions, right? For example, the 360p, the 480p, the 720p, etc., right? And you would have 1080p as well. This is what you actually see on YouTube, that the same video is encoded in different resolutions. So 360p actually corresponds to a height of a vertical height of 360 pixels. Similarly, 480 corresponds to a vertical height of 480 pixels, and so on, right? So lower the resolution, lower would be the size of the video that you end up loading. And for each resolution, there is a suitable bit rate as well, or the amount of data that we are going to be streaming every second. So for every resolution, there is a suitable bit rate range, and the video compression actually tries to fit the video within that bitrate range for every resolution, right? So your original video gets converted into multiple resolutions, and then it also gets divided into smaller chunks, right? So let's say this is a 30-second video. It will get divided into, let's say, 6 chunks of 5 seconds each. Just taking an example, right? So this is chunk 1, 2, 3, 4, 5, and 6. All of them are, let's assume, of equal length. Now, when a video starts playing, instead of loading the video using the single video file that we provide to the player, the video actually starts playing, let's say, at the lowest resolution, because this would be the one which is the smallest in size. It has the lowest bitrate available. So it starts off, let's say, at 360p for the first segment. It realizes that my network speed is actually great. So instead of loading my second segment, which corresponds to, let's say, the next 5 seconds of the video, instead of loading it over 360p, it switches to 480p and it loads the second segment from here, it realizes that the network speed is still better. It then moves up to 720p and it loads the third segment from here, and then it stays on 720p for the rest of the video file. This is what you typically see on YouTube as well, that you start a video, or any other streaming platform, that you start a video, it probably starts at a slightly lower quality, and then it just adapts to the network that you're having. It can move up the resolution or the bitrate, and it can also go down if your network quality degrades, right? So this is the key difference between progressive and adaptive streaming. What we have discussed till now was progressive streaming. We're now moving to adaptive streaming. A few things change when we move to adaptive streaming. One is that we cannot use the same MP4 file that we have. We need to create those different resolutions. We need to be able to divide them into chunks, and we need to inform the browser that, okay, these are the different chunks that we have available. Now, there are set protocols for it. So the two protocols that are the most popular ones are HLS and Dash. So in our application, we'll convert the MP4 video to use HLS adaptive bitrate streaming. The second thing is that once we have converted the video into smaller chunks and different resolutions, we have created a list of those chunks. The standard video tag does not understand that, right? So we need to have a specialized player to be able to stream that video correctly. In our application, we are going to be using hls.js. But there are other players like Video.js. There is, let's say, Exo player for Android. There's React Native video player. So there are a bunch of players that can actually load the adaptive bitrate streaming manifest, load it correctly, and switch between different quality levels as the user's network changes. Now, in our case, let's go back to our sample application, and I will change from the ImageKit video tag. I'll go to another component that I have, which is the HLS video player. I'll just walk you through the code for that in a second. So we'll use the HLS video player. Obviously, transformation is not something that we now need to pass, so we'll remove this. The HLS video player, as I had mentioned earlier, it uses HLS.js file. And again, in this case, I'm using ImageKit to transform my video from MP4 to the different segments that we need for HLS streaming, right? So the way to do that in ImageKit is that to your source, I just need to append ikmaster.m3u8. M3u8 is the standard extension that we have for an HLS manifest. And I need to add the representations or the different resolutions that I want for my video, right? So in my case, I'm using 360, 480, 720, and 1080. These are the standard representations that I want to load for every video. So I'm just appending my driving trip.mp4 file with ikmaster.m3u8 and the representations that I want. Now, if I go back to my application and I reload the page, you will now see that instead of a single video file that was loading earlier, we now have a master playlist that loads, right? Now, the master playlist has different playlists in itself. Each playlist has a different resolution. So this is 360p, 360 being the vertical height, 480, 720, and 1080. Then the bitrate is sort of indicated by this bandwidth number that's here. So you can see that the lowest bitrate or the lowest bandwidth is for the 360p playlist. So the player actually starts with the 360p playlist. It loads the first segment, which is now each playlist actually has different segments, right? So this video is divided into 4 segments. It starts the 0th segment at 360p. It realizes that the network speed is good. It moves up to 720, and then the last 2 segments are loaded at 1080, right? Very easy to implement video streaming with ImageKit. I didn't actually have to process these videos on my own. I just had to append ikmaster.m3u8 and the representations that I want to my video URL. Again, this is something that can be done with a lot of other services as well. It's just simpler to do it with ImageKit. So now let's quickly test whether our adaptive stream actually adapts to the user's network or not. In Chrome, you have this utility available where you can throttle the network. This is what we are going to use. So I will just throttle my network to a slow 4G to mimic a slow loading time. And let me refresh my page. Now, once the video starts loading, you can see that it starts off at the 360p playlist like I did earlier. But instead of upgrading the first segment to 720, it still stays at 360p. Now let's remove the throttling very quickly. It moved up to 480p. But it had already loaded all the segments that were needed, so it did not actually move up. Let's do another round of testing where we will start off without throttling, and then we will just slow down the network after the video loads. So without throttling, let me reload the page, and then we just move to slow 4G, right? So it still loaded the 1080p segment at for the second one, but it moved to 360p as well for the second one, loaded the third segment at 480p. So you can see that the player actually took into account the network change after it had started loading the second segment. It moved to a lower resolution 480p or 360p for subsequent segments to make sure that the stream continues even if the network fluctuates, right? So this proves that our adaptive bitrate streaming is able to adapt to the user's network, which can fluctuate over a period of time. Now, the next thing that we want to do is to resize the video, something which we have already discussed when we were discussing about progressive streaming. We resized the video to 900 pixels of height at that time. In this case, if I remove the throttling and if I just leave the player to its default settings, you can see that the player always goes up to 1080p. Now, again, it's great that the player decides to go up to 1080p because my network speed is great, but actually I do not need 1080p for this particular placeholder. I can do with a much smaller resolution as well. Even if I take into account the display density, it's a high density display, but still I do not need 1080p for this. Now in HLS.js, there are a few settings that you can change. These settings would vary depending on the player that you have, but there would be similar settings available for all the players. The two settings that I want to enable now is to cap the level to the player size. So they cap the resolution to the actual player size where the video is being played. And there are certain devices which exhibit a ratio, device pixel ratio of more than 2, but we are capping the maximum device pixel ratio to be used at 2. Now, if I reload the page now, you would see that even without any throttling, the video is still going up to only 480p here, right? Because, and the reason for that is that my player right now, the height of the player is 227 pixels, which is what you can see when I hover on this. Even if I multiply that by 2, that's approximately 454, which is still lower than the resolution that I would get from the 480p video that I'm loading, right? So the player, instead of going all the way up to 1080p, it sticks to the 480p segment. And you can see that there is a stark difference in terms of the total video size that gets loaded, right? So with 480p, all segments and playlists loaded, this is 2698 kilobytes. When we did not have these settings enabled, and when the player was loading a 1080p segment, you can see that the total video size was 11.3 MBs, right? So just by enabling this setting that we are capping the player size to the actual video placeholder and we are capping the max device resolution, we are able to optimize our video size significantly. So with the adaptive bitrate streaming changes that we did, the player was actually able to adapt the bitrate or change the resolution over a period of time. So we moved from 360 up to 1080 when the network was great. And it also came down when the network was not so great, right? So it worked both ways. And with the configuration changes that we did, the player did adapt the max resolution that it was loading to the device. Now, this is actually useful, for example, if you start in a portrait mode and then the user rotates their device to landscape, the resolution of the video actually needs to change because let's say the user has gone full screen. Earlier, they were viewing it in a small placeholder. So your player actually needs to adapt to the changing resolution as well. Now, while the video that we showed or that we are using in our demo application, that's just a 30-second video, but imagine someone loading a 20-minute episode on their device. They start off in landscape and then they move to portrait or vice versa. Then the resolution actually needs to change based on the actual resolution requirements of the device in that state. So with the setup that we have right now, the video player is able to adapt the bitrate as well as it is able to adapt the resolution to the device. Now, adaptive streaming looks great on paper, right? Because you're always able to adapt the videos to the user's network, you are able to adapt it to the user's device. It looks like the best way to stream videos on every device and on every website and app. But that's actually not true. The reason for that is that it does not come for free. You have to load an additional video player. In our case, we have to load the HLS.js video player, which in itself is a 1 MB JavaScript file. Now, because you have to load an additional file, which is 1 MB of additional JavaScript that will get loaded on your page, you really need to ask yourself that do you need this additional data load to happen? or can you do with just the simple video tag? And a few questions that you can ask yourself when you're thinking about adaptive streaming is that, one, are your videos even long enough to benefit from adaptive streaming, right? Because we looked in the example that we had earlier that it's only when your videos are actually of a significant length, let's say of a few seconds, 30 seconds plus, it's only then that they would actually have multiple segments and that your video would be able to benefit by switching from one resolution to the other as the network speed changes. You need to have time for the network speed to change, and then you need to have a long enough video that would actually benefit with the change of resolution as the network changes. So if your videos are actually not long enough, then you do not need to use adaptive streaming, right? If you have really short, maybe 5-second product videos, maybe some shorter animations that you have, you do not actually need adaptive streaming. You can just use a single video file, load it at the right resolution like we did in the beginning, and load it with this standard HTML5 video tag or whatever player comes natively with your application. Uh, the second use case where you would not want adaptive streaming is that you do not want the video to adapt at all. Now, imagine you have some beautiful animation on your product website that demonstrates the features of the product that you have. Or, for example, on our own ImageKit.io website, there are certain graphics that you would see on the homepage, which are actually videos where we explain the transformation parameters or we explain video optimization. Now, in those cases, we do not want a lower resolution where the text could go blurred or the quality could drop or our brand logo would not look great. We do not want these videos to be ever delivered in a lower resolution, irrespective of the user's speed, right? Irrespective of the user's network speed. We could possibly just give them an image, but we definitely do not want a lower resolution video to load on their devices. Now, if your business also has a possibility that you do not want your videos to adapt at all, then you should really consider that you should not be using adaptive bitrate streaming. Instead, you can use a single video that is encoded correctly in the right format and it's at the right resolution. And if you even need to degrade the experience, let's say for someone who has a poorer network speed, instead of loading a lower resolution video, you, like I said, you can probably think about loading an image instead of loading a video at all. But it would definitely be worth considering loading a single video file instead of adapting it. Now, in our application till now, the video was right at the top, right? So whenever the page loaded, we just autoplayed the video, which is great if the video is right at the top, but there could be certain cases where the video is actually far away from the top, right? And which brings us to, again, something similar to the optimization that we have for images, is that should we lazy load our videos, right? And when should we do that, right? So in this case, imagine you have a mobile device where there is a bunch of content that's there on the page, but the video is actually coming beyond the first scroll, or let's say beyond the visible viewport of the page, right? This is the video player that you have. Now, in such a case, it's fairly possible that the user lands on this page and without even scrolling to the video file, they just move away from the page completely, right? In such a case, if you were to start loading the video early when the page loads, the browser is then actually wasting its resources on downloading the video, which is not actually going to get played. And because of this competition, it has to delay or some of the more essential things like your JavaScript, your CSS fonts, or the page itself, they also start getting delayed, right? So a great practice for any asset that you're loading or any resource that you're loading on your page is to delay the loading to when they're actually required. So what we want to implement is that as the user scrolls down the page, and let's say your video is now, let's say, a few hundred pixels away from the bottom of the page, and it has started coming within that range, it is at this time that we actually want to trigger the loading of the video and trigger the loading of the player. To do that, we actually already had something like this implemented for our video application. If you look at the code, we have something called an intersection observer. We are basically waiting for the video player to be 100 pixels away from the viewport end or the bottom edge of the viewport. And we're saying that, okay, if 50% of my player is within that range, that's when you start loading the video, right? So that's what the 0.5 stands for. And if to demonstrate this, if I just move this particular response JSON, if instead of it being the first element, let's move it to the fourth element, right? So I'll move it over here, and let's save the file and come back to our application and reload the page, right? Now you can see that the first element is different, but till now there have been no requests that have been fired for the driving trip MP4. When I start scrolling the page, only when the player actually starts coming into the view, which would be after this particular card, now it starts coming into the view, and now you can see that the requests start going out, right? And again, because of all the other optimizations that we had implemented, it only goes up to 480p. The video has already started auto playing, but we actually delayed the load of the video till the time the video was actually needed on the page. Now, this is not just applicable to vertical scrolling, right? There could be a use case where, let's say, you have a product image carousel, you have product images, and maybe there are a bunch of product images, and the fourth or the fifth element is actually a product video. Now, the product video is not something that's visible to the user when they first land on the page. It's only when they start scrolling in this carousel would they actually get to the video. So again, this lazy loading is not just applicable to vertical scrolling, but even to horizontal scrolling where the video is not yet visible on the page. You want to wait for the user to actually get to the video before you initiate its load. Up until now, all the video streaming that we were doing, we were actually just autoplaying the video whenever the page loads. And even in case of lazy loading, we just autoplayed the video when the user scrolled to it, right? So if I just reload the page, the video is in viewport and it just starts playing. In most cases, it would be okay to pause for the user to actually click on the play button before you start playing the video, unless you're building an application like similar to an Instagram Reels or like TikTok, where you want the video to continuously just autoplay as the user scrolls through different videos. Unless you're building an application like that, in most cases, it would be fine to actually not play the video and wait for the user to interact with the video. Because in this case, you can see that I'm loading almost 2.7 MBs of data. The user may not have had the intent of actually playing the video as well. So to do this, we can actually remove the autoplay and the muted attributes on our player. It works for the HLS video player that we have. Now, if I reload my application, you can see that the video does not play, but it has still loaded all the segments, right? It has not yet played the video. I need to click on it to play the video, but at least the autoplay stopped. And similarly, even for the ImageKit video component, if I were to switch to that for progressive streaming, you would see that if I pass the autoplay parameter as false, and if I now reload the page, the video actually does not play. But again, even in this case, the player has already loaded 4.6 MBs of data, right? So at this stage, it should have loaded the full video size is 7.8 MBs. I have not played the video, but the player has still loaded 4.6 MBs of data. Now, this brings us to the next point or the next point of optimization. Obviously, we want to wait for the user to actually interact with the video before we play that. But the more important thing is that we need to be able to control what gets preloaded, because clearly pausing the video as well is not helping us so much, right? So the way to do that is that we can pass a preload parameter. This is a standard parameter for the HTML5 video tag. It's also supported in the ImageKit video component. I can, let's say, pass preload as none, right? So there are three different values: none, metadata, or auto. The default is auto, but let's start with the most aggressive one, which is preload none, which basically, if you see over here, it actually does what it says. It loads nothing, right? So I do not even know the duration of the video. I do not have the thumbnail of this particular video. In this case, there is absolutely no data that has been loaded at all. Now, to get that thumbnail, you see this poster attribute that we have for this component. I actually do not have a poster image, but ImageKit allows me to construct a poster image or a thumbnail image from the MP4 file itself. So I'll use my ImageKit URL endpoint, which is https ik.imagekit.io/ikmedia. And then I will use the media URL, which is the MP4 URL that I have. And I can append ik thumbnail.jpg to it to get a thumbnail out of the video. By default, it picks it up from the first frame of the video. So if I now load the page, I at least have the thumbnail that gets loaded for the video. Still, it's just 117 kilobytes of thumbnail. I can obviously resize this thumbnail as well, just like I would do for an image. Let's say I just resize it to width 900. And now if I reload the page, you can see that the thumbnail has a width parameter to it and the size is down to 36.3 kilobytes. So we're not loading any data till the time the user clicks on the play button, except for the thumbnail. Now, this is very aggressive for most cases. A better way to do this would be that if we change the preload to instead metadata, and I actually do not need then the poster attribute as well, so I'll just remove that, because when I set this to metadata, you can see that the player now has a thumbnail. It has loaded only a fraction of the video, probably the first couple of seconds or 3 seconds of the video. It's only 379 kilobytes of data out of the total video length, which is 7.8 MBs. It's just loaded 379 kilobytes of data till this stage, right? So for most cases where you can wait for user interaction, this is the best possible compromise, that you have a thumbnail, you're not loading a large amount of data, and only when the user clicks on the play button does the browser actually start sending out more requests for more content and loads the entire video. Now, this is what works for progressive streaming, but let's again go back to our HLS video player where we had the HLS.js player being used. I'll remove this autoplay attribute and I'll even remove the meta preload attribute because that's not something that works for HLS player. Instead, there are different settings, and again, there would be equivalent settings for different players. But in HLS.js, we have something called the max buffer length, which is what defines how many seconds of video will it preload. And then we have another parameter which is max buffer size, which defines the amount of data that it will preload, right? So there is a combination between these two parameters that the player takes into account. But now if I reload my page, you can see that it did not load up to the third segment, which is what was happening earlier. If you go back in the video, when we did not have this setting enabled, the player had actually loaded the entire duration of the video, all the 3 segments. Now with these two settings enabled, where we are capping the max data to 5 seconds or 1 MB, it actually stops at the first second itself. You can be more strict over here, that you can reduce the buffer length or you can reduce the max buffer size. Again, it depends on your use case and how much video do you want to keep preloaded when the user starts clicking on it. But you need to pass these two settings to ensure that your player does not actually load the entirety of the video even before the user starts playing the video, right? So when you wait for user interaction, you need to make sure that for progressive streaming, which is where we are using the standard video tag, that we are using the preload attribute. Either none or metadata would be good options over here. And if you're using a player for adaptive streaming, then you need to be able to control the number of seconds or the number of bytes that the player actually keeps in buffer. Now, an important distinction for videos, because videos are getting played over a period of time, is that the way that the user interacts with the video will also change. Now, imagine you have a 1 minute or a 2 minute long video, the user clicks on it and they start playing the video. But it is possible that after they click on it, they actually move away from that video and move to other parts of the page, right? In this case, you can see that even though I'm not viewing the video, the player is actually still loading the subsequent segments, right? It loaded the second segment, then it loaded the third segment. In our case, it's just a 30-second video, so it does not amount to a lot of data. We will still end up loading approximately 2.7 or 2.8 MBs of data. But imagine had this been a 1 minute, 2 minute, or let's say a 20-minute video, and the user is actually not viewing the video. They played it once, but then they moved away from it. Your player still keeps loading different segments in the background. In our experience, that's actually one of the key areas where you end up having a lot of bandwidth consumption, which is not at all useful for the user because they're in any case not viewing the video at all. But for a business, you end up spending a lot on video streaming costs because all of this data is going out from your CDN and you would end up paying for all this data transfer. So for videos, it's really important that apart from taking into account the network changes or the device resolution changes, which our player does for us, we also need to take into account whether or not the user is actually viewing the video or not. Similar to what we did for lazy loading, where we actually waited for the video to come into the viewport and then we started playing the video, we actually need to pause the videos when the user is no longer watching them, right? Now, we already have a piece of code written for this. I'll just uncomment it. So you can see over here that we are actually using the pause function that's available in the player. We're just checking that if the video is no longer intersecting on the viewport, that it's no longer a part of the viewport, and the user themselves, they have not paused the video, we actually need to pause the video on behalf of the user so that the player stops streaming more content, right? Now let's look at a quick demonstration for this. I will first play the video and then I will just move away from the page. In this case, you can see that there is a console log that comes which says pause playing. If I again come back, it again starts playing the video. It's at the third second. I'll just move away again and it pauses the playing. If I come back to it, it again starts with the sixth or the 7th second. And you can see that if I now move away from the player, it no longer loads the third segment of the video. Now, this is applicable again, not just for cases where the user needs to scroll to view the video, but even in, let's say, product carousels where let's say the user viewed the product video once, but then they swiped right and moved to other images or other media content for that particular product. You need to actually pause the video because your player otherwise would keep playing the video in the background, and as a business you would end up losing out a lot on media delivery costs, right? So keep this in mind. This is perhaps the most important optimization technique, especially if you have very long videos, that you should pause the videos when your new user is no longer watching the video on the page. So this brings us to the end of our video on video optimization for websites and apps. To quickly summarize what we discussed, when you're doing progressive streaming, that is, you're using the standard HTML5 video tag with just a single video file, always make sure that you're using the right codecs and the right container format, and you're compressing your video, or you're reducing the bitrate. Reduce the resolution, make sure that it's right for the placeholder or the player where you actually need to load the video instead of loading the highest resolution that you have available. And a more aggressive strategy applicable to both progressive as well as adaptive streaming is to remove the audio completely, especially if you're using some background videos. You should use adaptive bitrate streaming, especially if you have longer videos that would actually benefit with the network changing and with the video adapting to those network changes or to device changes. But don't use it if you have really short videos that actually won't benefit, or you don't want them to adapt to lower resolutions in different cases. Remember to lazy load your videos. These are huge objects. Typically, they would be in few MBs. There's no need to load them upfront. You can actually wait for the user to either click on the play button to play the video, or even if you have to implement lazy load, then you need to wait for the video to come closer to the viewport to actually stream it instead of loading it beforehand. When you are waiting for the user interaction to play the video, you also need to be able to control what gets preloaded, right? You need to limit the amount of data that the player would keep in its buffer before the user clicks on play button. And most important, when the user is no longer viewing the video, just make sure that you're pausing the video player so that the player does not keep streaming the video and does not keep loading more segments of the video on its own, even when the user is not playing the video. Now, this is a list of optimizations. Not all of them may be applicable to your business use case, but from this list, you can pick the ones that are suitable for the kind of application that you're developing. But you can be assured that if you implement all of these, you would have the best possible video streaming experience for your users. And as a business, you would be controlling costs for media streaming as well. If you want to access the documentation for ImageKit, you can head to imagekit.io/docs and refer to the documentation. And if you want to refer to the code that we used during this video, the link for the GitHub repository is there in the description, but you can access it from the ImageKit samples repository on GitHub. I hope this helps you implement video optimization correctly on your websites and apps.